Hello and welcome to my presentation. So today I will be talking about odds ratio and relative risk and how this has various applications to health data. And we will look at one particular set of data that comes from the CDC. Okay, so let's start off by talking about why we actually study relative risk and odds ratio. So often in research, we want to determine whether an association between two variables is present. And specifically, sometimes we will look at associations in what are called 2x2 contingency tables. So we have two variables of interest and we want to see whether they are associated or not. So there are a couple ways to do so that we have discussed in the course. So the first one we looked at was difference of proportions. So this, we just took the proportion 1 minus proportion 2, and it gave us an estimate of the difference between the two. But sometimes this wasn't very insightful, as we'll see on the coming page. Next, we talked about relative risk and the odds ratio, which will be the focus of this presentation. So now that we've talked about these, let's briefly begin by defining some basic terms. So let's first define what the risk and the odds are. So risk in statistical terms is just the probability of a certain event or outcome occurring. So for instance, you want to know what is the risk of contracting some disease in a certain population. And then we'll talk about odds. So odds in statistical terms is the ratio of the probability of an event occurring relative to the probability of the event not occurring. Okay, and next we will examine how relative risk is defined and why it is needed to help explain associations in the 2x2 contingency tables we have studied. So why use relative risk? So we just talked about the difference between the two proportions, so it actually could be misleading. So for example, if we have that the difference between two proportions is equal to 0.05, so 5%, we could get this difference in many different ways. So let's look at these two cases below. So we have 0.07 minus 0.02 could give us a difference of 0.05, so that's 7% minus 2%. Or we could also look at 0.51 minus 0.46, and that is also a 5% decrease, or yes, decrease. Then to more accurately measure the change in probability. So here we already had the probability was quite low, and then it changed to something even lower. Here in this case, we had the probability was quite high, and it didn't change as much relatively. So what we want to do is more accurately measure this change, and we will do that by taking the ratio of P1 and P2. So by doing that on this first one here, we had that P1 was 0.07 and P2 was 0.02. So then taking the ratio of those two, we have 3.4, and then doing similarly the same thing on the right-hand side over here. 0.51 over 0.46 gives us a relative ratio of 1.109. So these two are the relative risk calculations from this. And we often use relative risk, which will denote RR, when the study involves comparing the probability of an event occurring between two different groups. So in this case, we see that the change in probability was obviously greater for the one on the left-hand side than on the right-hand side. Basically, the probability went down by 3 times, or the probability was 3 times greater before than it was after. Now let's define relative risk. So the relative risk is the ratio of risk of an event in one group versus the risk of the event in the other group. So in most health studies, we consider one group to be the individuals who are exposed to a disease, and the other group will be the ones that are not exposed. So now that we've kind of briefly introduced this, let's talk about the example we're going to use. So the example from the CDC we'll look at on the next slides calculates the relative risk with the following formula. So in the numerator, we have the risk of disease in the group of primary interest divided by the risk of disease in the comparison group. Okay, so the data that we're going to be looking at is provided below in the bottom right-hand corner, and it looks at tuberculosis infections at a prison in South Carolina in 1999. And we want to determine is whether there is an association present between tuberculosis infections and the wing in which the prisoners are housed. They could be housed in the east wing and the west wing. We want to see if which wing they're in affects whether or not they have tuberculosis. So let's first do that by doing the relative risk. So by calculating the by calculating P1 and P2, we get that P1 is equal to 28 over 28 plus 129. So that's just 28 over 157 or 0.178. And similarly, we can find P2 by taking 4 and dividing it by 4 plus 133, and that'll give us 0.029. Then we can find the relative risk of this by taking the ratio of P1 and P2. So that's 0.178 divided by 0.029, and that gives us a relative risk of 6.138. So now we want to interpret, what does this relative risk of 6.138 mean? We can conclude from this relative risk of 6.138 that the inmates housed in the east wing are 6 times more likely to contract tuberculosis than the inmates housed in the west wing. That is obviously indicated by the number of people in the east wing that have tuberculosis is 28, and obviously the one number in the west wing is very small at 4. So if we just talked about this, then why do we want to use odds ratio if we already have an idea of how to compare the two probabilities between groups? So this is where we come up with odds ratio, because in retrospective studies, so this is case control studies, we don't have the total number of exposed people available in all cases, so we can't calculate that relative risk. So in this case, the odds ratio is used to measure the strength of the association between the exposures, so whether you're exposed to something or not, and the corresponding outcome of interest. So the odds ratio is the ratio of the odds of an event in one group versus the odds of the event in the other. In health studies, we are mainly interested in what the odds of being exposed to some disease are versus the odds of not being exposed. And now we're going to move on to using that CDC example earlier, and then we're going to calculate the odds ratio using the following formula. So this is known as the cross product formula. So here I have P1 times 1 minus P2 divided by P2 times 1 minus P1. Then we're back to the example we had earlier. And again, we want to see are the two variables of interest associated using this odds ratio idea. So doing this, we have the odds ratio is equal to 28 over 157 times 133 over 137, all divided by 4 over 37 times 129 over 157. And that gives us an odds ratio of 6.217. There is an easier way to do this. So to find this odds ratio here, you just take this A entry, multiply it by the D entry, and then divide that by the C entry times the B entry. And if you do that, you still get 7.217. Now we want to interpret, what does the 7.217 mean? So this tells us the odds of getting tuberculosis if you're housed in the east wing is 7.217 times the odds of getting tuberculosis if you're housed in the west wing. Now let's compare these two, the relative risk and the odds ratio. From the CDC example, we found the relative risk as 6.183 and the odds ratio was 7.217. So in this example, we can see both of these calculations are obviously larger than 1. And something we want to recall is that a relative risk of 1 and an odds ratio of 1 indicate that the two variables of interest are not associated. Obviously, these two measurements we calculated, the relative risk and odds ratio for this example, are obviously greater than 1. So we can see that the prisoners wing they are housed in and the number of tuberculosis infections are obviously associated because these two, odds ratio and relative risk, are obviously larger than 1. So when do we want to use relative risk and when do we want to use odds ratio? So in the CDC example, we have been discussing which quantity makes more sense to rely on. So in my opinion, I think relative risk makes more sense because it gives us a sense of how the probability of getting tuberculosis in one wing is so much larger than the probability of getting tuberculosis in the other wing. And this is because relative risk tells us whether there's an increase or decrease in the likelihood or probability of an event based on some exposure. So I think that makes more sense in this case. However, whenever we have retrospective studies, as I mentioned earlier, the total number of exposed people we may not be available. So the relative risk can't be calculated. So in that instance, we need to use the odds ratio to measure the strength of the association. However, in prospective studies, so cohort studies, whether the number at risk is actually available, we can use either the relative risk or the odds ratio. And that is why in this presentation, I used both methods, because we had the number of people at risk, we had the corresponding number of people that were infected. So we were able to calculate the relative risk and the odds ratio from that example. So now we want to tie relative risk and odds ratio to the big picture of this course. So for this course, we have been studying different ways to analyze categorical data, whether it be through contingency tables or logistic regression models. So we want to know, how do these methods we are studying in this course apply to real world applications? In this presentation, I showed that via relative risk and odds ratio, we can help to determine if a relationship or association between two variables is present. In this case, we looked at tuberculosis infections, the number of those, and we were seeing if there was an association between those and the wing in which the prisoners were housed in. And obviously, we saw there was a relationship there. For instance, it just says right here, the analysis of the CDC data could give health executives at the prisoner institution an idea of how to combat this risk of contracting tuberculosis. So for instance, they could maybe not have as much contact in one of the wings that has a higher contraction rate of tuberculosis. We could probably keep those prisoners maybe farther apart. That way they don't get a higher chance of contracting it through the air pathogens, or they maybe don't come in close contact with other prisoners. So that could be something that some health executives at that corresponding prison could look at to help combat the high contraction of tuberculosis in one of the wings compared to the others. So now in conclusion, we can see that odds ratio and relative risk give us a little insight into how to determine whether association is present between two variables. And these two calculations are widely used in health science communities today, and specifically in epidemiology. And that is the end of my presentation. And thank you for your attention. And here are some references that I pulled some of the materials from. And thank you for your attention and have a good day.